Hello, bachcho. Let's read the question. The question says that the energy levels of an atom is shown in figure. Which one of these transitions will result in the emission of a photon of wavelength 124.1 nanometer? Given h is equal to 6.62 into 10 to power minus 4 joule second. So we will solve this question. First of all, we will see what will be the key concept used in the question. The key concept used in the question will be delta E, that is difference in energy level, is equal to hc by lambda, where h is Planck's constant, that is given as 6.62 into 10 to power minus 4 joule second. It is actually 6.62 into 10 to power minus 34 joule second. And c is speed of light, that is 3 into 10 to power 8 meter per second. And lambda is the wavelength, that is given as 124.1 nanometer. So that will be 124.1 into 10 to power minus 9 meter. Another formula which is similar to this formula is just we are changing the calculation. Delta E is equal to 1242 divided by lambda in nanometer. And this delta E should be in electron volt. We will use this formula because we have delta E given in electron volt and we have also lambda given in nanometer. So we will directly use this formula to find the corresponding transition. Now for the transition A, that is for this transition, we have delta E of A is equal to 2.2 electron volt. So we will just put the values to check what will be the lambda in this case, that is wavelength of the photon emitted in this case 2.2 will be equal to 1242 divided by lambda. So from here lambda in case of A will be equal to 1242 divided by 2.2, that will be equal to 564.5 nanometer. So this is not the required transition. Now for transition B, we have delta E of transition B as 0 minus 5 minus of 5.2, that is 5.2 electron volt. So that will be equal to 1242 by lambda of B. So from here we have lambda of B is equal to 1242 by 5.2, and that will be equal to 1242 by 5.2, that is equal to 238.84. So this will not be the answer. Now we will check for transition for transition D. So delta E for D, that will be equal to 0 minus of minus 10, that is 10. So that will be 1242 by lambda of lambda of D. Now from here we have lambda of D is equal to 124.2 nanometer, which is approximately equal to 124.1 nanometer. And this error in calculation, slight error in calculation is coming due to the value 1242. This is not the accurate value. It is actually 1241 point something. So that slight error is coming, but we can neglect that error. So the answer will be the transition D. So the correct option will be option D. Hope you all understood it well. Best of luck.